OK, to wrap up firewalls, what's good about them and what's bad about them? So we already said they give us centralized control. There is a single machine or firewall that you have to control, and it gives us security for all of the computers. It also gives us centralized management. So if we change our policy, we just change the firewall. We don't have to go and tell every single user to update anything. We just change one firewall. It can be transparent. So you could publish your firewall policies and let everyone know what they are. I think Berkeley probably does this somewhere, where they tell all of us what their firewall policies are. And once again, this allows us to defend against vulnerabilities on a bunch of end hosts with a single machine. What are some downsides? Well, because you're blocking certain packets, you might be affecting usability. So there are some applications that don't like being inside a firewall. Some of their packets might get mistakenly dropped, and this might affect users' experiences where they want to use something or access a website, but unfortunately, it doesn't work because the firewall drops it. Also, one big problem with firewalls is that there is no protection against attackers inside the network. So if you look at the pictures we've been showing you over and over again, the firewall is only inspecting traffic if it's from the outside coming in the network, or if it's from the inside going outside the network. If this employee sends an email to this employee, that packet doesn't travel across the firewall at all. From the firewall's perspective, it's not thinking about that packet at all. It doesn't even know that that email exists. So if somebody inside the network is malicious, like this computer gets hacked, or this employee gets bribed to do evil things, the firewall is not going to help you at all. This evil computer can attack all the other computers, and the firewall is not going to drop any of those malicious packets. So we do have to be careful. The firewall doesn't help with the threat model where somebody inside your network is malicious. So maybe an employee gets bribed, someone pays them to be malicious. Maybe somebody brings in a malicious cell phone from outside the network, and they bring it inside the office. Now it's connected to the network. And once you compromise one device, they might be able to compromise other devices. So that's one downside of firewalls. You could solve this by maybe building multiple firewalls. Maybe you build a second firewall between all of your employees and like a trusted set of administrators. That's something you could do. But that's one downside with firewalls as presented. OK, all done. So here's the summary. First half of this section was all about denial of service, where we attacked the availability of services. That was a new property that we previously hadn't seen. And we said that you can summarize or categorize denial of service by how it's attacking and where it's attacking. So first, decide how it's attacking. Are you crashing the server on purpose? For example, doing a buffer overflow or entering some input that causes the server to divide by 0 and crash. Those are one type of DOS attacks. And the other type, which we spent most of our time talking about, was exhausting all of the available resources. And the other type of classification is where it's happening. So you could either attack the code that the application is running. For example, one of those algorithmic complexity attacks where you feed in an input with the worst case runtime. Or it could be a network level attack where you flood the network by sending so many packets that the routers and the links cannot keep up with all the packets that you're sending. And within network level DOS, we saw DDoS, where multiple computers target a single server. And we also saw amplification, where you take a small input and turn it into a large input with the help of some third server, like a DNS name server. As for defenses, we saw that you can try and isolate different computers so that crashing one doesn't affect the other. You can enforce quotas. You can filter packets, although that can be difficult with distributed DOS. But those are some possible defenses. And we also saw that every attack can be defended against if you just get a lot of resources. That makes it harder for someone to overwhelm your resources. And CDNs like Cloudflare act like insurance to let you pool your resources. Then we saw one concrete example of denial of service attacks. We saw SYN flooding, where somebody spams a bunch of SYN packets, forcing the server to start a bunch of open TCP connections. It calls malloc to allocate state on every TCP connection, and it might run out of memory. To defend against this, we use SYN cookies, where the server doesn't allocate state right away. It sends the state back to the client, forces the client to create state first, and then send the cookie back to the server. And only after the whole handshake is done will the server actually create state. So this is useful because now instead of the server going first, which gives the client a big advantage, the server forces the client to allocate state first, so the client's asymmetry advantage is erased. Then in the second half, we talked about firewalls. Defend against a lot of devices with a single firewall. Use a security policy to decide what packets are allowed, disallowed. Firewalls implement those policies using packet filters, which decide whether to forward or drop packets. If your packet filter is stateless, then you just choose depending on the packet itself without looking at any other context. If the packet filter is stateful, then you also use past connection history, and you keep track of a table of all active connections to decide what to allow and what to drop. But attackers can subvert the packet filters. For example, they could split up the letters, they could exploit the TTL, and get around your packet filter. And at the end, we saw proxy firewalls, where the firewall creates a connection with both sides separately and forwards packets on behalf of everyone inside and outside. And we also saw VPNs, which allow someone to go outside the network, but still enjoy the benefits of the firewall by tunneling into the network.